This is a clip about heat capacity and specific heat capacity. So let's start with heat capacity. Say you have two kettles, one is half full, one is full. Of course you know that it takes a lot less time to heat the water in the half full kettle in comparison to the one that is full. That is because you have the same amount of energy provided per second, and if you have more water, it just takes longer to heat that amount of water, the larger amount of water, to the same temperature. Heat capacity is defined as the amount of energy taken to raise the temperature of an object by 1 degree Celsius or by 1 Kelvin. Heat capacity is presented by the capital letter C, and it is defined as the heat energy, which is presented by capital Q, divided by the change in temperature, delta T. So here is an example. Say you have a piece of rock and you take 5,000 joules to heat it up by a temperature difference of 10 degrees Celsius. Then the heat capacity of this piece of rock would be C equals Q divided by delta T. That would be equal to 5,000 divided by 10 degrees Celsius. So that would make 500 joules per 1 degree Celsius. Now let's have a look at specific heat capacity. Specific heat capacity can be compared to heat capacity just like density and the mass of an object. When we talk about density, we actually talk about the mass of one particular volume, usually 1 centimeter cube or 1 meter cube. The same applies to specific heat capacity. We're actually looking at how much energy is needed to increase the temperature of an object by just 1 degree Celsius. Therefore, we use a slightly different formula here, and we use the small letter C to denote specific heat capacity, and now we divide Q by the mass as well, apart from the temperature, or change in temperature rather. So let's have a look at how specific heat capacity and heat capacity or thermal capacity are related to each other. Specific heat capacity, small c, is basically equal to the thermal capacity of an object divided by the mass of that object. And just to clarify again, the units used here, the specific heat capacity would basically be measured in joules per kilogram per degree Celsius, the thermal capacity in joules per degree Celsius, and the mass, of course, in kilograms. So the definition of specific heat capacity is the energy required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius, or 1 Kelvin. So let's have a look at an example. We have 1 kilogram of water and say we want to increase its temperature by 10 degrees Celsius, and it takes 42,000 joules of energy to do that. Then the specific heat capacity will be 42,000 divided by 1 and divided by 10. So that makes 42,000 divided by 10 makes 4,200 joules per kilogram per degree Celsius. Just a few cool facts about specific heat capacity. If you look at the specific heat capacity of water, it is actually a fairly high value in comparison to what you have, for example, for iron or for lead, for any of the metals. And that is why water is actually still used as a coolant in the car engine. You would assume that after this many years you would probably have a more advanced coolant, but water, due to its high specific heat capacity, is still the coolant to go for. It also means that if you take a hot shower in the morning, it actually takes a fair bit of energy to heat up that water, much more so than if you took a shower of pellets of lead.